Let us now look at the basic logic gates. The first one is the AND gate. The AND gate can be defined as one of the simplest logic gate. So we are concerning about the output. So it says the output is true only if all the inputs are true. So what does that mean? We have the gate and it has input and produce the output. The input must be in binary and the output will also be given in binary. In most systems, I have mentioned previously that the output is the response. By using a system, we want to control the response of the system. All we care about is the output of a system. So in this example, it says we want to control the output to be true with respect to the condition that all the input of this particular gate must be true. The term true I have mentioned previously, which represent binary 1, and it also represent the state on and with the analog value of positive 5 volts. If we mention true 1, on or 5 volts, which represent the signal in and out of the gate, we may use them repetitively. For example, the false, on the other end, it is given with binary 0, which is equals to the state, which is off, and the analog value of 0 volts. This represents the off state. So with the digital system, we normally use this binary, but the false, on and off are used interchangeably, but they all mean the same thing. From the left, we have the symbol of the AND gate, and this is the package view of the AND gate. This is the identification number, or we call it the part number of the chip, because there are many chips and packages available in the market. If you want to buy the AND gate, which is the chip, you will identify from this number. And inside the package, you can see we have 1, 2, 3, and 4 AND gate inside this particular chip. And the physical component can be seen in this figure, where it has pin 1 to 7, and on the other side is 8 to 14, as you can see from the package view. And this is the reference point of most of the chip. Because there are no labels given in the chip, you will identify the chip through this opening given. We can see that example for this particular AND gate, 1 and 2 will be the input, 3 will be the output. Same as for this AND gate, we have 4 and 5 as the input and 6 is the output. And in this chip, it needs power supply to operate, because in order to get the 5 volts or a 0 volts as the ground, you need a supply. So in that case, the pin 14 represent VCC is normally connected to positive 5 volts, and the ground is normally connected to a 0 volts. So during this operation, this chip will get high from this positive 5 volts or false 0 from the ground. That is why every chip normally have what is known as a power supply. In the previous video, we make mention that we have analog component, and those analog components make up a digital component. And I have made mention in the video of how to understand a transistor, and by understanding the transistor, it is important because by using those transistors, we can build those logic gates which will provide us with a binary 1 or the 0. So for this AND gate, let us see how it is constructed using a transistor. This is a diagram of a transistor, and I will give an example of the NPN transistor. This is NPN. If you haven't watched this video, the link is given in the description below for you to see how the transistor operate. And we have another NPN transistor which is connected to the ground, and this is normally the positive 5 volts from the supply, and this is the 0 volts from the ground. So comparing it with the symbol, you can appreciate that we have two input. A and B is the input, and where can we get the output? The output is connected here, so we can say V out. From the two state, the on and the off, you can be able to know what is a switch. When the switch, we say when the switch is closed, it is equals to the on state. When the switch is off, it is corresponding to the off state. By understanding how the switch operate, you can also be able to understand how this transistor operate. By using a switch equivalent circuit, we can be able to describe how the transistor operate. So imagine we have a switch which is given like this, and we rename it as A, and also we have another switch as B, and it is now connected to a light bulb, and we have the positive 5 volts. So you can see both these circuits are similar. Previously in our transistor video, we explained that a transistor normally acts as a bridge for the current to pass through an electric circuit. That is why a switch can represent this scenario. I will now explain. When we want to give the output 1, that means both the input must be 1. Therefore, we can apply 1 at input A and 1 at input B. In that case, when we want the switch to have a value of 1, it is corresponding to the on state. That means we are now closing the switch. So we close this switch and we close this switch. When we close this switch, this becomes a closed loop circuit, and current will flow through in order to light up this bulb. And if any of these switch is off, that means the output will be low. The condition is that the output will be 1 only if the two or all of the inputs are true, else the output will be low. I will now draw the truth table that will represent this operation. This is now the truth table that represents the operation of this particular AND gate. We will see that the output will be I only when both the input A and input B are I. For other combination, it will be low. How do people come up with such combination for A and B? For example, combination 1, combination 2, combination 3, and combination 4. We have the number of input. We normally say in terms of this combination 2 to the power n will give us the number of combination. And it is true where n represents the number of input. To increase the number of input, that means what do? You will increase the number of input. In this example, for this particular chip, you have only 2 input. In some other circuit, you will have more than 1 input for a particular AND gate. And in that case, when you increase the number of input, you will also increase the number of the combination. When n increases, the number of output combination increases. So 2 to the power of 2 will give us 4 combination, which is 1, 2, 3, and 4. And this is also important for you to understand. So let me briefly explain this truth table with respect to this diagram. For the first combination, you have both the input 0. That means if you apply 0 volts, what will happen to this transistor? This transistor will be off and this transistor will be off. Therefore, the current will not flow through these two transistors, which will now leave the output at 0 volts because there will be an open circuit. That means the switch is open and this both switch is open. So no current will pass through the circuit. So this light bulb will be off. For the second combination, you have the input A, which is 0 volts. However, you have 5 volts at input B. So what will happen? This transistor will be off and this transistor will be on. That means if you look at this diagram, this switch will be off and this switch B will be on. Because although switch B is on, that means that we apply 5 volt to the second transistor. The first transistor is open, so the bridge is open, so no current will pass through this point. Therefore, which will leave, although this transistor is on, there won't be any current flowing through. That means the current cannot flow in this region because this switch is off and the output or the light bulb will be off. Therefore, we say the output is also 0 volts or in the low state. For the third state, we say input A is 1 and B is 0. That means input A we apply 5 volts and input B we apply 0 volts. Although the first transistor will allow the current to pass through because it is on. However, the second transistor is off. Therefore, no current will pass through this region. Therefore, the output will be 0 volt. That means this switch is on and this is off. So, the current will pass through the first switch while the second switch is off. So, no current will pass through the lamp. Therefore, the lamp will be off. And finally, for the fourth combination, we have both the input is I. That means we apply 5 volts as I have explained previously. That means this two transistor is on. So current will pass through first transistor and all the way to the second transistor and it will pass through the output. Therefore, the output will also have positive 5 volts. In the switch equivalent circuit, we say the first switch is on, the second switch is on. Therefore, we now have the flow of current to this closed loop circuit. And what will happen to this light bulb? The light bulb will glow. Now, I will give you a real life example of how the AND gate will operate. In this example, if we have room 1 and room 2, they are both common by having air conditioning system. So both share the same air conditioning system. In order for this system to supply cool air to the room, that means the condition is that both the rooms must have a temperature greater or equal to 30 degrees Celsius. Temperature greater or equal to 30 degrees Celsius. When the temperature is greater than or equal to 30 degrees Celsius, it will have a binary state 1. So this will be the condition. If one of these temperature is less than 30 degrees, the air conditioner will not supply cool air to this particular room. Therefore, in order for these air conditioners to supply cool air to both the rooms, that means both the rooms must have temperature greater than or equal to 30 degrees. So with this example, I believe you can be able to understand clearly the condition of how the AND gate operates. If both these rooms have temperature less than 30 degrees, it will represent a 0 state. So the air conditioner won't be turned on. And if only one of these rooms has high temperature and the other one has low temperature, still the air conditioner won't be switched on. The air conditioner will switch on only when both the rooms have temperature greater than 30 degrees Celsius. Finally, we can provide a summary of this in terms of a mathematical representation such that AB, which is the output, is equals to A dot B. That means if you think as a multiplication, that means if we multiply binary, 1 times 1 will give the output 1. If any of these have 0 value, 1 times 0 will be 0, or 0 times 0 will be 0. If you like our video so far, you can click the like button and subscribe to our channel to stay tuned for more updates. And finally, we can proceed by saying with this video, for the AND gate, you can now be able to know what is a symbol for the AND gate, the package view, and the physical component, and you can fully understand how they create a transistor, and from this transistor, they create the digital logic gate such as the AND gate, and how the AND gate will operate based on the condition of the input to produce the targeted output. And you can also use this AND gate for application where there are conditions. If you have more input that is true, that means it will provide the output which is also true. For example, in a switching phenomena. In our next video, we are going to look at what is the OR gate.